Welcome students. We are going to start today with a new type of integral problem, and the type is integral a cos x plus b sin x divided by c cos x plus d sin x dx. Now in this, remember a, b, c and d are real constants. What are they? They are real constants. They are not variables. They are real constants. They are real numbers. So if we have any such problem, then how do we integrate? What we are going to learn? If we have a problem of this type, then how do I integrate it? Okay. I give you an example for this. For example, suppose you have to integrate a question. You have to integrate a function wherein you have the function as sin x plus 2 cos x divided by 3 sin x plus 4 cos x. So how would you integrate this? So for integrating this function, you will have to use the method which I am going to now tell you. So this is the type, and now I tell you the method. See the method. Method is express the numerator in terms of denominator and derivative of denominator. So I want you all students that you say this statement 2-3 times. Okay, what is the method? The method is express the numerator in terms of denominator and derivative of denominator. Okay, so as per the method, what we are going to do is we will express the numerator. See, this is numerator. What is it? It is a cos x plus b sin x. We will express the numerator in terms of denominator, and derivative of denominator. Now how is that going to happen? Okay, so that we will see, but before that I will write that is to obtain two constants, in fact real constants. So I should write here two real constants a and b, such that two real constants a and b such that numerator is equal to denominator. Numerator is equal to a into denominator plus b into d by dx of denominator. Okay. So now I'll tell you what is this. See students, as you wrote here, what you will do is you will try to find two numbers A and B. You will try to find two real numbers A and B such that this is possible, such that this is possible. What is possible? Such that numerator could be written as A into denominator plus B into derivative of denominator. This is the method. I repeat again. I will look for two constants, C, A and B. I will obtain these two constants A and B such that the numerator could be expressed as A into denominator plus B into derivative of denominator. So you can check, you can say that A and B are the actual thing that we have to work for. So let's begin. So here I will start with this question only. Let me start with this question. This is question number, this is exercise 3.2. This is exercise 3.2 and second question, fifth sub question. Okay. So I will solve the same problem. So let's begin. See how do I. So the first step, as you all know students, I will write I equals to, let I equals to sin x plus 2 cos x upon 3 sin x plus 4 cos x and dx. Okay. So what I have to do, I have to express numerator in terms of denominator and its derivative. So I will write let sin x plus 2 cos x equals to A into denominator. What is A? 3 sin x plus 4 cos x plus B into derivative of denominator, d by dx of 3 sin x plus 4 cos x. Okay. So the next step you will get, students. See what will be the next step that we will get. So the next step, I will get sin x plus 2 cos x equals to A into, don't multiply this A inside, please. So A into 3 sin x plus 4 cos x plus B into, differentiate this, differentiate. So you will have 3 cos x and derivative of cos x is minus sin x. So this will become minus 4 sin x. Okay. And this I will write as equation number 1. This is my equation number 1. Remember. Okay. What is next step? Next step is, now I will multiply this A and B inside the bracket. So see, I will get sin x plus 2 cos x equals to 3A sin x, 3A sin x plus 4A cos x plus 3B cos x minus 4B sin x. Okay, minus 4B sin x. So next step, see what will happen. Next step will be sin x plus 2 cos x. Sin of x plus 2 cos x equals to, check. Students, check. See, this is sin x and here also you have sin x. So I take sin x common from these two terms. Okay. So what I will get? I will get sin x out, 3a minus 4b in the bracket. So I will get 3a minus 4b sin x. Okay. Further. Further students, check this. Here you got in this term cos x and here also you have cos x. Take cos x common. You will get 4a plus 3b. 4a plus 3b. So you will take plus cos x common plus. So you get 4a plus 3b cos x. Now students, the left hand side and the right hand side are equal. Okay. The left hand side and the right hand side are equal. So on the left here you have sin x into 1. What is coefficient of sin x? 1. So this becomes, I will write therefore 3a minus 4b equals to 1. This is equation number 2. And here I have 4, see here 4a plus 3b equals to 2. Coefficient of cos x is this and coefficient of cos x on the left is 2. So I have 4a plus 3b equals to 2. This is equation number 3. Now what I will have to do, students, I will solve for a and b. So I write here multiplying equation 2 by 3 and equation 3 by 2. I multiply this equation by 3, okay, and this equation by 2. So what I will get, see, multiply 3. So 9a minus 12b equals to 3. 9a minus 12b equals to 3, and here what I will get, 8a. Oh, students, I made a mistake here. This I should have written what? Multiplied by 4. Okay, let me change this. Multiply equation 3 by 4. Multiply equation 3 by 4, not by 2. So here you get, when you multiply this by 3, you get 9a minus 12b equals to 3, and here you multiply by 4. So 16a plus 12b equals to 8. Now we add this. This cancels. When you add, you get 25a. 25a equals to 11. So a is 11 over 25. We got a. Now what I do next is I use this a in any one of these equations to get the value of b. So I write here using a in equation 2. Using a in equation 2. So you get 3 times 11 upon 25 minus 4b, equals to 1. So you have 33 upon 25 minus 1 equals to 4b. I take 4b on the left so that it becomes positive. 33 upon 25 minus 1. So this becomes, 25 is LCM. 33 minus 25 equals to 4b. This is 8 upon 25 equals to 4b, and b equals to 2 upon 25. What is b? Okay. And here a is 11 upon 25. What is next step, students? After getting the value of b and a, I will use this to here in this. Please understand, this is the step. This is the step where I'm saying, what am I saying, students? This is the step where I'm saying the numerator is expressed as denominator and derivative of denominator. Remember, this is the denominator, and here what is this bracket? It is derivative of denominator. So the numerator is expressed as denominator and derivative of denominator. So I will write, using a and b in 1 we get, I write here, using using A and B in 1, we get, see students what I get. I get, what was numerator? Numerator was sin x plus 2 cos x. Okay, so sin x plus 2 cos x equals to, remember what it was? It was A into denominator. A into denominator. What was A that we found? We found A as 11 upon 25. So 11 upon 25 and denominator was 3 sin x plus 4 cos x plus b. B is 2 upon 25 into derivative of denominator. The derivative was this, 3 cos x plus 4 sin x. 3 cos x minus 4 sin x. Students, so you succeeded. You succeeded. Succeeded in what? You now can say that the numerator is this thing. See, what is this? What has happened, students? This was the numerator. This was the numerator, which what you will do now, you will write this numerator as this thing. So the integral will change. Try to understand. So the new integral will be, what will be the new integral, dear students? It will be, therefore, I equals to, you remember what was numerator? Numerator was sin x plus 2 cos x. Sin x plus 2 cos x. But don't write it. Write what? Write this full. So the numerator I will write 11 upon 25. What was A? A was 11 upon 25. 11 upon 25 into denominator, which is 3 sin x plus 4 cos x, plus b. B is 2 upon 25 into derivative of denominator, which is 3 cos x minus 4 sin x. What I did, I expressed the numerator in terms of denominator. And what is denominator? Denominator is 3 sin x plus 4 cos x. You know, students, after this, what I will do? Yes. After this, what I will do is, I will split the denominator for these two terms. One is this and the other is this. So see, the next step I will get. The next step I will get is integral. I will get 11 upon 25 plus, what happened? This will cancel when you will separately divide. When you will write this whole thing upon this, 3 sin x plus 4 cos x will cancel. So you are left with only 11 upon 25. That was the trick, my dear students. That is why we did it so, because we wanted to have it transformed. You remember the word transformation? What is happening? This is all transformation happening. Plus 2 upon 25, 3 cos x minus 4 sin x upon 3 sin x plus 4 cos x dx. And you know, students, the next step, I will write separate integral. So integral of 11 upon 25, which is a constant, 11 upon 25 dx, plus integral of this whole thing. You understand? Yes. So here, see what I will do. What I will write is 11 upon 25 being a constant, it is out, I write, and here I get 1 dx, integration of this, but it is a constant, so I wrote it out. So I'm left with 1 only, plus when I write integration of this thing, now in this I notice 2 upon 25 is constant. 2 upon 25 is constant. So 2 upon 25 I write out an integration of 3 cos x minus 4 sin x upon 3 sin x plus 4 cos x dx. Okay, now check. I equals to 11 upon 25. Integration of 1 is x plus 2 upon 25. And here, see students, what do you notice? Here, what do you notice? Oh, how simple it is. The numerator is derivative of denominator. That was the trick, my dear students. If you remember, here what we have b into derivative of denominator. This thing is derivative of denominator. See, that was the trick that we did. We expressed the whole numerator as denominator plus derivative of denominator. So now when you know that numerator here, this is f dash x and denominator is f of x. When you know that numerator is a derivative of denominator, like here, the answer is log of mod of denominator. So log of what you have, you will have here log of, you will have here log of mod of 3 sin x plus 4 cos x plus c. This is final answer. Okay, you can again replay the video and watch this. This is an important type of problem. Thank you.